All right, let's dive in. Today, we're going to build a Java program from the ground up. We're talking about the absolute essential pieces, the building blocks that let you take an idea and turn it into code that actually does something. Have you ever just sat back and wondered, how does that even work? How does a thought in your head become a real working program on a screen? Well, it's kind of like building with digital Legos, and today we're going to look at each one of those bricks and see exactly how they snap together. So first things first, before you can build anything, you need a plan, right? A blueprint. The very first puzzle you have to solve in programming is, how do you describe a thing from the real world in a way a computer can understand? And the big idea that helps us do this is something called encapsulation. It sounds complicated, but it's not. It's really just about bundling stuff together. You don't just have data floating around. You package that data up with the specific actions that can work on that data. Everything gets wrapped up in one neat, tidy little bubble. In Java, that little bubble, that blueprint, is called a class. Think of it as a template or a cookie cutter. To make this super clear, let's try to model something we all know, a simple circle. Okay, so what information do we need to describe a circle? Well, inside our class, we create what are called fields. For a circle, that's pretty simple. It needs a radius, and it needs some coordinates for its center, let's say an x and a y. These fields hold the unique data for each circle we create. But a circle isn't just a set of numbers. It should be able to do things, and that's where methods come in. Methods are the actions, the verbs. For our circle, an obvious method would be to calculate its own area. See how the data, the radius, and the action, calculating the area, are now bundled together in the same blueprint? That is encapsulation. Okay, so we have our blueprint. We've defined what a circle is in theory. But a blueprint for a car isn't a car, right? You can't drive it. So the next big question is, how do we take that blueprint and create an actual living, breathing circle in our program? And this brings us to a super important distinction you've got to get right. The class is the blueprint, the cookie cutter. The object is the actual cookie you make from it. You can use your one circle class to stamp out dozens of unique circle objects, each with its own data. Maybe one has a radius of 5, another has a radius of 20, same blueprint, different results. So how do you make one of these objects? It's like a little 3-step dance. First, you declare it. You basically tell Java, hey, I'm going to need a variable to hold a circle. Then you instantiate it. This is where you use the magic new keyword, which tells Java to actually build the object in its memory. And finally, you initialize it, which means giving it its starting values. Now that last part, the initialization, is handled by a very special method called a constructor. It's easy to spot because it always has the exact same name as the class. Think of it as the factory that assembles your object. And what's really cool is that you can have more than one constructor, giving you different ways to build the same object. That's a nifty feature called overloading. So for our circle, what would that look like? Well, you might have one constructor that just takes a radius and automatically puts the circle at the center of the screen. But you could have another constructor that takes a radius and specific x and y coordinates. It just gives you, the programmer, more flexibility. Okay, great. So we've designed a blueprint, we've created actual objects, they're sitting there in the computer's memory, but so what? If we can't see what's happening, it's not very useful. How does our program actually talk to us? How does it tell us the area of that circle it calculated? For that, we use what's called standard output. You've probably seen prints line before. The ln just means line, so it prints whatever you want and then hops down to a new line. The basic print command does the same thing but stays on the same line. And then there's printf. The F is for format, which is what you use when you need to be really precise, like controlling how many decimal places to show. So our program can talk. That's a huge step. But a good conversation is a two-way street, right? To make our programs truly interactive, we need a way for the user to talk back to the program. We need a way for our program to listen. Yep, it's the other half of the equation. Our program can talk, but how can it possibly listen? How do we ask the user, hey, what radius do you want for your circle? And then actually get their answer? In Java, the most common way to do this is with a fantastic tool called the scanner class. And again, it's a simple little process. First, you import it, basically telling your program you want to use this tool. Second, you create a new scanner object, and you tell it to listen to system.in, which is just a fancy programmer term for the keyboard. And finally, you just use its methods, like .nextInt to grab a whole number, or .nextDouble to grab a decimal. Simple as that. We have covered a lot of ground here, from an idea all the way to an interactive program. So let's just do a quick fire recap of these core building blocks we've been talking about. Let's lock this in. The class, that's your blueprint. The object, that's the actual thing you build from the blueprint. The constructor is the special method that does the building. A method is any other action the object can do. Standard output is your program talking to you, and standard input is you talking right back to it. You get these 6 ideas, and you've basically got the foundation of all of Java. And really, this is where all the fun starts. You've just seen the fundamental Lego bricks for building just about anything you can imagine in Java. We've laid out all the pieces, so there's really only one question left. Now that you know the building blocks, what are you going to build first?